Okay, so for acids, we need to know that acids are, I'm sorry. Let's start with the similarities. Both acids and bases are electrolytes. And let's go over what exactly do we mean by an electrolyte. So an electrolyte is a substance that produces ions when it dissolves in water. So in other words, both acids and bases, when they dissolve in water, that's going to produce ions when that happens. And then both acids and bases have the ability to change the color of pH indicators. And they also both will react with each other, like acids and bases react with each other in neutralization reactions to produce water and a salt. Okay, then the rest of these properties, you need to know them backwards and forwards and upside down for both acids and bases. So for example, acids produce hydrogen when they dissolve in water. Acids will always contain more H than they do OH. When added to water, they increase the hydrogen ion concentration. They decrease the OH minus ion concentration. They decrease the pH, and they have a pH of less than 7. Acids turn litmus paper red. They have no effect on phenolphthalein. Phenolphthalein is a pH indicator. Acids taste sour, and they also react with certain metals to produce salt and hydrogen gas. Okay, now let's take a look at bases. Bases produce OH ions when they dissolve in water. They contain more OH than they do hydrogen. When added to water, bases decrease the hydrogen ion concentration. When added to water, bases increase the OH ion concentration. When added to water, they increase the pH. They have a pH of greater than 7. They turn litmus paper blue. And they also turn phenolphthalein to pink. Phenolphthalein, again, is the pH indicator. And then bases taste bitter and feel slippery. So I just try to remember that the B in basis is supposed to be B for bitter. And you can also remember that the B in basis is supposed to be B for blue. Okay. And then neutral substances, they have a pH of equal to 7. And then they also have equal amounts of hydrogen and OH. Okay, now let's take a look at Arrhenius' theory of acids and bases. So sometimes scientists would define acids and bases differently. So, for example, Arrhenius, he defined acids as substances that produce hydrogen ions when they dissolve in water. And the hydrogen ions that were produced from the acid combined with water to form the substance hydronium. So you need to know that technically hydrogen ions and hydronium are kind of the same thing, especially when we're talking about acids and bases. Okay, so now let's see, let's take a look at the example. In the example, we're taking HCl, an acid. When we drop it into water, it splits and produces hydrogen ions and chlorine ions. And then the hydrogen ions combine with water to make hydronium. Okay. Now for Arrhenius acids, acids usually begin with H. That means like if you're staring at a substance and it's asking you, oh, which one of these is an acid or a base? All that you have to do is just figure out which one starts with an H. Literally, that's it. If it starts with an H, then that's the acid. And if it doesn't, okay, then that's not the acid. Okay, now let's take a look at, oh, actually, let me show you an example from practice 1. So this is an acid, this is an acid, that's not an acid. This is an acid, this is an acid, that is not an acid. How can I tell? It just doesn't start with an H. It has to start with an H. It can't just have an H in it. It has to start with the H. So this one does not start with an H. This one does, but then this one does not. So it'd be option 4. Okay, now let's take a look at bases. Okay, so for bases, bases are substances that produce OH ions when they dissolve in water. Most bases are ionic for Arrhenius. So bases usually have a metal and an OH in them. So that means that you need to be a little bit familiar with the periodic table and know which elements are metals or nonmetals. So it has to have a metal and an OH. So let me go back to practice question 2. So here, this has a metal and an OH. Potassium is a metal. Calcium is a metal, and then that's also an OH. And then this is not a metal and an OH. Okay, and then Let's see, this is a metal and OH, this is a metal and an OH. That's not a metal and an OH. That's a metal and OH, that's a metal and an OH, that's also a metal and an OH. So it'd be option 3. Okay. Okay, now let's go ahead and take a look at the other definition of acids and bases. So acids and bases can also be defined differently. Right, the other scientist is Bronsted-Lowry, and his definition was only slightly different. Okay, so a Bronsted-Lowry acid is a substance that can donate a hydrogen ion during a reaction. So that's very similar to the Arrhenius definition. Okay, then the Bronsted-Lowry definition of bases, that's what's very, very different. So Bronsted-Lowry bases are substances that accept hydrogen ions when they dissolve in water. Okay, so basically Bronsted-Lowry oh, I totally lost my train of thought. Basically, Bronsted-Lowry didn't even bother with OH or not. Basically, Bronsted-Lowry only only cared about if the substance was losing a hydrogen ion or gaining a hydrogen ion. Okay, now let's take a look at how to figure out if a substance is a Bronsted-Lowry acid or not. Okay, so what we do is we need to pick a substance. So we need to pick either, okay, actually, wait, let me back up a second. Only the left side of the reaction can be an acid or a base. So not the right side. We're not going to label those as acids or bases. Okay, so what you do is you're going to pick a reactant. So remember, reactant is a substance on the left-hand side. I lost my train of thought. So it doesn't matter which substance we pick. We can pick the water or the NH3. So I guess we can pick the water. And then we need to, okay, wait, this is the reactant side, and this is the product side. So we need to figure out what product the H2O became. And it's very, very important to keep in mind that the only thing that should be changing is the H. Yeah, the only thing that should be changing is an H. So that means if it has an O on the left, then that means it has to have an O on the right. Okay, so that means that the substance that it became is OH minus. Yeah, the O does not change, for example, into NH4 plus. That does not make sense. Okay, so we need to figure out if the H2O lost a hydrogen or if it gained a hydrogen in order to become OH minus. Okay, so it seems like the H2O must have lost a hydrogen because it went from having two hydrogens to having only one on the H2O. Okay, so it must have lost a hydrogen ion. So substances that lose hydrogen ions, those are acids. So that means that H2O is the acid. Okay. Now we also need to know that After the acid loses a hydrogen ion, the substance it became is called the conjugate base. Okay, so that means that OH minus is the conjugate base. Okay, now let's take a look at the other substance, the NH3. So, like I said, we pick a reactant. So, the reactant is NH3, and then the OH minus. I'm sorry, the NH3. We need to figure out what substance it became. So, again, the only difference should be the H. So that means that if it had an N on the left, then that means it's gonna have N on the right. Okay, and then let's see. That means and then we need to figure out whether the NH3 um we need to figure out if it lost a hydrogen or gained a hydrogen in order to become NH4 plus. So it must have gained a hydrogen because it went from 3 hydrogens to 4. Okay, so and then we need to know what substances gain hydrogen ions. That must be NH3, or I'm sorry, bases. Bases gain hydrogen ions. After the base gains a hydrogen ion, the substance it becomes is called the conjugate acid. So that means that an H4 plus is the conjugate acid. Okay. I'd like you to try questions 5 and 6, and then what I will do is I'll be back in a minute or two while you do 5 and 6.
Yes, ma'am.
Right, sorry, I'm back.
Yes, ma'am. For Number one, it's gonna be 2.
Yes, good.
And oh, sorry, that was for number 5. And then for number 6, I was thinking number 1.
Yes. Yeah, perfect.
Okay.
Okay, now let's say pH is supposed to be the measure of hydrogen ions or hydronium ions in a solution. Okay, and then acids are substances with with pH of values less than 7. Neutral substances have a pH of equal to 7. And then bases have a pH of greater than 7. Okay. Let's say the strength of an acid or base can be determined by the pH value. Strong acids have very low pHs, and then strong bases have very high pHs. Okay. Now, let's go over what exactly do we mean by a strong acid or base. Okay, so what makes something a strong acid or a strong base is the ability to completely dissociate, or in other words, split into hydrogen ions. Okay, so let me write this out. Strong acids completely dissociate when they dissolve. Versus weak acids will not. Let's say that we have um, let's say that there's 100 HCl molecules. Then what happens is for these 100 HCl molecules, all of them will completely split when they dissolve in water. So that would make 100 hydrogen ions and then 100 Cl minus ions. Okay. Now what happens is that weak acids will not do that. Okay, so weak acids do not completely dissociate when they dissolve in water. So let's say that we have a different acid, maybe HF. Okay, so what happens in a weak acid is that not all of the molecules will split. Okay, so let's say that when we drop the HF into water, maybe 60%, um, like the 60% of the molecules will split, and let's say that makes 60 hydrogen, and then 60 fluorine ions, then that means that the other 40% don't do anything. They actually stay together. Okay. So right, that's the whole point, is that they don't completely split. Some of them stay together. All right, now. Oh, actually, we need to mention something about the hydrogen ions. So, because the strong acids, they produce more hydrogen ions, then that means that they're going to be more acidic. Yeah, actually, hold on, let me write more hydrogen ions means more acidic. And therefore, there's going to be a lower pH. Okay, so that means that the HCl could have a pH of maybe 2 or 3. But the HF, basically, the fewer the hydrogen ions that there are, the less acidic, and therefore it's going to have a slightly higher pH. Now, it's still going to have a pH less than 7 because it's still producing hydrogen ions when it dissolves, but it just makes fewer hydrogen ions, so the pH probably would be maybe like 5 or 6. Okay, you could try 9, 10, and 11.
For number nine, two.
Sorry, pardon?
For number nine, it's two.
Mm-hmm.
And for number 10,
Okay, you there?
yes, ma'am.
Okay.
And for number 10, it would be number three.
Mm-mm.
Oh my gosh. Which aqueous solution would have a pH of 3?
So first for 10, is it an acid or a base that we're looking for the pH?
A base.
Mm-mm. Acids have pHs of less than 7.
Yes, ma'am. Acid.
Okay, and then yeah, so basically we're looking for an acid. Acids, they usually begin with H. So the two substances that begin with H are option 1 and option 4. But option 1 is water, and water always has a pH of 7. So it should be
Yes,
option
ma'am.
4.
Yes, ma'am. Thank you.
Hmm.
For number 11, it would be 1.
Yes. Okay. Okay, so let's take a look at pH indicators. Okay, so the common pH indicators are litmus paper and phenolphthalein. So phenolphthalein, right, is a substance that dissolves in water to produce a colorless solution. Okay, and then acids have no effect on phenolphthalein. And then bases are substances that change phenolphthalein to pink. So when we add phenolphthalein to a base, it turns pink. Okay, then now we need to look at litmus paper. Okay, so acids are substances that change litmus paper to red. So when we dip litmus paper into an acid, it should turn red. Okay, and then litmus paper, when you dip it into a base, then it turns blue. Okay, that's it for pH indicators. We don't need to know about any others other than um, phenolphthalein and litmus paper. Okay, now let's take a look at concentrations of ions. Okay, so acidic solutions always contain more hydrogen than they do OH, always. So actually, let's take a look at this first sentence that I skipped. Any solution with water contains both hydrogen and OH ions. I think a lot of people get stuck into thinking that things that are acids are only going to have hydrogen. That's not true. Or that bases only have OH and that neutral substances don't have any, but that's not true either. Basically, even pure water still has hydrogen and OH ions. Still. Okay, so, okay, and then the stronger the acid, the greater the OH ion concentration. Or I'm sorry, the greater the H concentration, I meant. Okay, now neutral substances, they have equal amounts of hydrogen and OH. And then basic solutions contain more hydrogen than, I'm sorry, more OH than they do hydrogen. Okay.